Sometimes when we're solving equations, we need to first combine like terms. We don't want to have multiple terms that have the same variable in them. So we need to combine the coefficients of those terms. If we're looking at example 1 here, I have in parentheses 2x squared minus 6x minus, in parentheses, negative 2x squared plus 3x. So before I can do anything, I need to get rid of these parentheses. Our first set doesn't have any kind of coefficient, so we can really just remove those parentheses, and we're left with 2x squared minus 6x. The second set of parentheses, however, has this negative sign in front, and that really is a negative 1. So we're going to need to use the distributive property to multiply this negative 1 by each term on the inside of the set of parentheses. So we're left with negative 1 times negative 2x squared would be a positive 2x squared, and a negative 1 times a positive 3x would be a negative 3x, which is the same as minus 3x. Okay, so from here, what we need to do is combine things that are the same. So it looks like there's an x in each of these terms. However, 2 of them have x raised to the second power, and 2 of them have just plain old x. And that's a difference. So we need to combine all of our terms that have x squared. So I'm going to put them in a box. It helps me organize my thoughts. As I keep going through, I can see here that I have another one that's an x squared term. And that's it for x squareds. So then I'll go back to the beginning and I'll look at my next term. So I have a negative 6x. I'm going to put that in a circle to distinguish it from the terms I already have in boxes. So are there any other x terms? Well, sure, right here. This negative 3x. So I'm going to put that in a circle as well. So from here, what we need to do is combine the things that are in the same shape, that have the same terms, that have the same variable for that term. So 2x squared plus 2x squared would mean my x squared just stays the same, and we're adding the coefficients, the number in front. So positive 2 plus 2 just gives me a 4. All right, so I've combined these already. Now I look at the circles. I have a negative 6x minus 3x. So those two signs are the same, so we add them and keep the sign. So minus 9x. And that is the simplified version of our original problem. So now we only have one x squared term and one x term. So that's the goal. So if we take a look at another example, it's very similar to the first one. We have 2 sets of parentheses here, but there's a plus sign in the middle. Because that's a positive, and if I were to multiply by a positive 1, that doesn't change anything, I can really just get rid of those parentheses altogether. So we'll bring down our 2y squared plus 9xy plus 3y squared minus 2xy. So now this one has a whole lot of things going on here. We have a y squared term in our first term here. We have xy in our second. We have another y squared, and then we have an xy. They have to be exactly the same if we are going to combine like terms. So I'm going to put my first term in a box, and I'm going to look for all of the other y squared terms. I found one right here, that positive 3y squared. And you'll notice that I'm keeping the sign inside the box. That's really important because when you combine them, you're going to need to know if it's a positive or a negative. So that's all my y squared terms. So I'm going to go to the next one. My next term has an xy for the variable. As I look through, I have another xy term down here. I'm going to keep that negative inside the circle. And now I'm going to combine my like terms. 2y squared plus 3y squared is 5y squared. And then positive 9xy minus 2xy is positive 7xy. And that's it. So we have combined our like terms to make our statement as simple as possible.